Hello and welcome to the Horns and Whistles Workshop YouTube channel. My name's Mark. Thank you for joining me on this video, which is a product demonstration and installation tutorial video for the Hornby Ringfield motor upgrade kits, which are available to purchase online. If you have a look at the product description below, there'll be a link to where you can purchase these kits. My intention is to explain how these kits work, give you a live demonstration of fitting one from start to finish, and then at the end of the video we'll put the completed model with the new motor on the test track. We'll put some coaches or some trucks behind it and we'll give it a run. One thing to mention before I start is this video relates purely to the motor upgrade kits supplied by Horns and Whistles Workshop. The reason I mention that is in recent months some sellers on eBay have literally produced carbon copies of these kits, and they've even gone as far as copying and pasting the content of my eBay product description without even bothering to change the font, without even bothering to hide the fact that it's a copy. And they encourage you to search for this video as an installation guide for their kits. I just want to mention that because this video is for the kits that are made and sold by me at Horns and Whistles Workshop. And there are some things about these kits that make them unique and different to other kits that are available online. So there are 4 different types of motor you can buy, and I've got an example of each laid out here. The motors come in 2 main sizes. You have a 12-volt motor, which is a 12mm thick motor, and you have a slimline motor. Now I'll just bring in an example of each of those. So this is the 12-volt motor here. As you can see, that depth there, you have to take my word for it, is 12mm. And then the slimline motor, of which this is one, is 9.5mm deep. You can see there, as I hold them up together, the difference in the depth. They both have an 8mm long output shaft, and they both have a few inches of trailing wires. Now, in terms of why there are several different options, the 12-volt motor, the wider motor, is suitable to go on what's known as a BoBo configuration model, or a BoBo configuration bogie. BoBo simply means that each end of the locomotive has 2 axles. Examples of that would be something like a Class 43 HST intercity train. This is the motor bogie from one of those, and as you can see here, the motor protrudes out of the chassis wider than the gauge of the wheel. However, there's a big enough gap between the axles so that the motor doesn't actually interfere with the wheels. So you can fit a reasonably thick or a reasonably wide motor in a model which has got 2 axles at each end, such as a Class 43 HST or a advanced passenger train, a Class 33, anything with a BoBo configuration, you can fit one of these 12-volt motors in. The slimline motor is the motor that you need if you have got a diesel locomotive with a CoCo configuration, which means 3 axles on each bogie, or a tender-driven steam locomotive. The reason for that, as you can see here, is the centre wheel. Oh, I knew that would happen. The centre wheel overlaps where the motor is, and if you had a wide motor, it would effectively mean that you couldn't fit this centre wheel. So you need this slimmer motor to sit flush with the chassis. Sorry, those wheels aren't actually held on by anything other than my fingers, so that you have got room to put your centre wheels on. If you had the 12-volt motor, then this motor would be sticking up another 3mm, and then it would get in the way of this wheel. So if you have a steam locomotive where the Ringfield motor is in the tender, or a CoCo configuration diesel such as a Class 37 or a Class 47, then you need the slimline motor. In relation to the slimline motor, that motor runs quite quick. It's a 6-volt motor, It's not possible to make this slimline motor a 12 volt motor purely because it's not thick enough or deep enough to put enough copper winding in. So this will run probably a significantly faster speed than your model originally did. That is just a side effect of these motors, but it doesn't cause any issues. It just means you don't turn the power up quite so high if you're running analog. Or if you're running digital, then it's not an issue at all, because you can use the speed curve CVs 2, 5 and 6 on your decoder to set an appropriate speed curve and limit the top speed. So these run absolutely fine. And these are the only, as far as I know, at the time that I record this, the only slimline 6 volt motor available on the market with an 8mm motor output shaft. The other options that are available on the market, of which I think I've got an example, are these. So the other people that sell them sell this sort of motor here. Now, if I pop this out, you can see that the output shaft on this motor is significantly shorter. It's about 4 or 5mm. Now that does create a bit of an issue when you want to put the shaft or the pinion gear on the motor, which we'll get to when we demonstrate how to fit it. But the motors that are sold by Horns and Whistles Workshop, the slimline motors, are the only ones available, because I've had a motor supplier make them specifically for me with an 8mm output shaft. And the other sellers that have copied the idea don't have that. Their slimline motors will have a really short stubby shaft. In relation to the 12 volt motors, you can see from the labels here there are 3 different types. And the types are differentiated by the speed at which they run. So the slowest of them is the Hornby DMU or rail car motor, which has a top speed at 1/76 scale of 70 miles per hour. Now these 3 have been specifically designed and made for me by my motor supplier to give you this prototypical speed. None of the other motor suppliers are able to offer you this, but I've done quite a lot of work, quite a lot of research and product testing with a motor supplier, and they have provided me or supplied me with motors that run at specific RPM at 12 volts, which is the sort of full power on a DC layout, to give you this prototypical speed. So you have a 70 mile an hour motor, which is suitable for DMUs and rail cars. You have a motor which runs at a top speed at 90 miles an hour, which is typical for most of your BoBo freight diesel locomotives. And then you have one that runs at 125 miles an hour, which is obviously for your HSTs, your advanced passenger trains, your class 2, 2.5s, etc. So those are your options if you have a BoBo model and you can fit a 12 volt motor, and they will give you the benefit of genuinely realistic scale speed. Now I'm going to be doing this video demonstration fitting a slimline motor to this Coco diesel class 47. If you want to view a really good video of how to fit one of the BoBo variants, one of the 12 volt variants, I've put a link in the bottom to a video by Chadwick Model Railway, who did a video using these kits that were supplied by me to him a while back, and he demonstrates them fitting it to a class 43 HST. So if you are fitting your motor to a class 43 or something similar, a BoBo model, a BoBo diesel, then I would suggest you actually go and watch Charlie's video from Chadwick Model Railway, because it is a really, really good video. I'm going to be doing it using a slimline motor, which is this one, into this class 47 diesel. We'll fit it and I'll talk you through how I'm doing it, and then we will give it a run. So without further ado, let's get on with it. First thing I will do is show you what you get in the bag and show you what tools you're going to need. So your motors will come in a bag and they will have a sticker on them denoting which type of motor it is. Once, however, you get your motor out the bag, particularly if you buy a few different types of the 12 volt motor, the actual motor itself isn't labelled, nor is the 3D printed adapter. The only thing that labels it is the bag, so make sure that you don't mix up your motors and mix up your bags. So in each bag you get a CD drive motor slid into a 3D printed plastic fitting adapter. You get a little round paper sticker, and if I tip the rest out here, you get a length of heat shrink tube, you get a pinion gear, and you get three, the listing says you get three little E-clips there, which are to fit the fitting adapter onto the chassis. In this bag there is actually a fourth, and some of you may find that if you buy it, you've actually got 5 or 6 of them in your bag. It depends how many I pick up when I pinch. I pick up a pinch out of the pot. Sometimes it's easier just to drop the 5 in rather than to put them back and start again trying to pick 3 out. So you may, although you get a minimum of 3, you may end up having a few more of those. You only actually need 2 to complete the installation, but they are a bit fiddly and they tend to ping off if you're not careful with them. So the intention of providing you with at least 3 is just so you've got a spare, so that if you do lose one, it's not the end of the sort of exercise. So let's get on with this class 43. So the first thing we need to do is pop the body off, and that is simply just done by running your finger along this edge between the bottom of the body where it joins the chassis, and there's 3 clips on each side. You can see the clips, there's one there, and one there, and it's the same on the other side, and they correspond to 3 little slots on the chassis, which you can hopefully see, one there, and one there, and the same on the other side. And obviously the weight there wasn't stuck in, it just fell out. That's absolutely fine. So that's the body off. We'll put the body to one side. We don't need that. We don't want it to get damaged or in the way, so I'm just going to put it to one side. Now I've got the body off, what I'm actually going to do is just explain to you what tools you need to complete this job. So the first thing I would suggest you have is just a little pot, so that when you're taking bits apart, you can put them in the pot so you know that things aren't going to get lost. So I'm going to pop that weight in there. Tools for completing the job: you're going to need a pair of pliers, needle nose pliers preferably. You're going to need a pair of wire cutters. You're going to need a set of wire strippers. These are a really good set to use. You're going to need a pair of tweezers and a couple of screwdrivers. I've got one flathead and one crosshead screwdriver here. You're going to need a 2mm punch and a reasonably small, probably describe it as a medium-sized hammer. You're going to need some solder and a soldering iron, which has gently reminded me to plug my soldering iron in so that it's nice and hot when we need to use it. So those are the things you're going to need. It's also worth having some basic model railway cleaning equipment, so a rag, a few cotton buds, a bit of IPA or your chosen cleaning fluid. One thing I will do is I'll put a product link to these wire strippers in the video description, because they are really good quality and they're really useful to have. So here we have our class 47 without a body. This could just as easily be now a class 37 or any other CoCo freight diesel. The installation is exactly the same process. So the first thing I'm going to do is I'm going to disconnect the power from this bogie to the motor and remove the motor. It's worth mentioning at this point how these models actually work. So you have obviously 2 rails that the model sits on, and on a DC circuit you have polarity across the rails that provide your current that goes into the motor. You have positive on one rail and negative on the other. It doesn't matter which round that is, because if you switch the polarity, the model just reverses direction. Now on these models here, you will see that one side of the motor bogie has got rubber traction tyres on the wheels. Now that obviously means that those wheels can't pick up power because they're insulated from the track. So the way these models work is, on the motor bogie, the wheels that don't have any rubber on, which, let's say this is the front and it's travelling that way, these wheels here are on the left rail. They pick up the power from the left rail, they transfer that power through the metal chassis, through a little wire, into this contact here. The power from the other rail is taken, so if you to the other motor terminal here, from this wire to the trailing bogie, which picks up power from the opposite rail, this rail here, which, if we're travelling in this direction, is the right hand rail. So one of the rails is conductive into the motor bogie, and one of the rails is conductive into the dummy bogie, transferred to the motor through this wire. So what we need to do is, when we fit our new motor, which obviously has two wires coming out of it, one of the wires needs to connect to the dummy bogie, one of the wires needs to connect to the motor bogie. That will give you a complete circuit, and that will mean your model will run on analog. So first thing I'm going to do is just disconnect this wire. This has just got a spade connector, a female spade connector going over the male contact strip. It just pulls off like that. And then I'm going to take the motor bogie out of the chassis, which quite simply means just bending back this little sort of sprung clip there, and then it will just fall out. You don't need to bend it back very much at all, and it should be sort of reasonably flexible. The only thing I would mention is, if you do anything like this in a shed or a garage which is cold and you do it in the middle of winter, things like this will become really, really brittle when it's really cold. So what I would suggest you do is, if you're going to do this and your model has been sat out in a cold environment, a cold shed or a cold garage, just put it completely assembled on a warm radiator for 10 minutes. It will just make everything a bit warmer and a bit more pliable, so that you're not likely to cause any damage to it. And there's no reason whatsoever why this process should cause any damage to your model. So having taken the motor bogie out of the chassis, I'm just going to put the chassis to one side, and we'll bring it back a little bit later, and we're going to focus on the motor. So I need to take this motor chassis out of the sort of plastic cowling, the decorative cowling that it comes in. So with my flathead screwdriver, I'm just going to pop the end of the screwdriver in the gap between this little sort of plastic sprung tab that we bent back to release it from the chassis, and there'll be a small gap between that and the metal of the motor housing. And if I put my screwdriver in there and just gently bend, actually ignore me, I'm doing that at the wrong end. You want to do it at the end with the coupling. Put your screwdriver in there, gently bend, and you can just see there it pops out quite easily. Now, the reason I realised I was doing it at the wrong end is because if you look at, there's two little tabs at the bottom of this chassis. So there's one here just below my finger, and there's one at the other end. One of them is wider than the other, which is why I looked at it like that to see which end I needed to do it at. You need to bend away where you have the wider tab, because it's also shallower. So that can be put to one side with my chassis, and you'll see my two little wheels there just fell off. There's two little sort of stub axles here, and those centre wheels are just held in place by that plastic housing that we've just removed, and having removed that, they have fallen off, which is where I bring in my little pot and put the wheels in the pot. So we need to disassemble this, which is quite a simple process. So first thing I want to do is take these pancake gears off. So I have this brass retaining strip here, which just with my flat-headed screwdriver, I'm just going to lift them off the two little axles that are on the gears, and just, there you go. Once you've got the second one off, it just falls away, and then the gears themselves lift off really easily. You can do it by hand, or if it's easier, sometimes it's easier, just use a pair of tweezers to lift your gears away. Now, one thing I'm going to suggest that you do is, before you put these gears in your little pot, and I will do this, is to give them a clean. So with your chosen cleaning product that I mentioned earlier, just a damp cloth with these plastic components will be absolutely fine. Just give them a clean. Make sure there's no grease, fluff, hair. If you run your model railway on carpet, you'll find they're probably full of sort of fluff. You really want to get rid of that to make sure your motor is going to run as well as it possibly can. Give them a clean, give them a wipe, and the brass retaining strip, give them a clean and a wipe, put them in the pot. The next thing I'm going to do is remove this wire here. So I mentioned earlier that the power to this particular contact strip of the motor is transferred through this wheel here and that wheel there into the metal chassis. It then goes through a wire which is connected to the chassis with a little spade connector here, the other end of which connects to this motor terminal. So I'm going to pull that off, and I'm going to pull it off the chassis as well. Should come off quite easily. You're going to need to use that, so we're going to keep that, put that in our little pot, and then I'm going to take this keeper plate off. So the keeper plate, the black plastic plate here, which has these two contact strips attached to it, has 4 little clips that you need to undo. One here, and then 2 in the underside. One there, and one there. So if I just gently lift the ones at the top and encourage them back through the holes in the chassis, you'll see that that has started to come away. If I then go to the bottom ones and just bend them back ever so slightly and push them through, there you go, you see that's coming away nicely, and that has just fallen away. Now it has left stuck to the chassis, although that wouldn't normally happen, this little stub axle here. You need to keep that because that's what one of your wheels goes on. So I'm going, oh, it's stuck to the magnet, that's why. I'm going to take that off and pop that in my pot. Now the rest of these bits here, the keeper plate, and we've also had fallout to springs and brushes. You don't need to reuse them. However, I wouldn't suggest you necessarily, I mean, unless the carbon brushes are in really bad nick, it's always worth keeping them just as spares. So if you do have another little pot or somewhere to put them, then pop them in there to keep them, because you never know when you might need a spare motor spring, carbon brush or anything like that. And the keeper plate as well. This, I should mention, this motor upgrade is entirely reversible. So if you keep everything from the original motor, if you decide to sell the model but you want to keep your upgraded motor, you can just completely reverse this and fit everything of the original motor back. We're not actually damaging or destroying anything, we're just taking it apart. It could be put back together again if you wanted. So you're left here with sort of a bare chassis with your armature in there, surrounded by a ring magnet. That's why these are called Ringfield motors, because the magnetic field is in a ring. And then on the other side of that, you've got your output shaft with your pinion gear on. So what we need to do now is knock that output shaft out so we can take it away and remove the pinion gear. So what I'm going to do is just open up the vise so that the opening is just slightly wider than the width of that armature, so that when I put it over that opening and use my pin and hammer to knock it through, there's enough width for that to pop down. So taking my 2mm punch and my hammer, I'm just going to locate the punch on the output shaft, and then I'm just going to give it some encouragement, shall we say. There we go. Took a little bit of persuading. Sometimes they are easier than others. It depends how sort of old the model is. But as you can see, that has knocked the shaft through the pinion gear and the armature just comes out. So having taken that armature and the pinion gear out, I'm just going to pop them in my pot of spares, which I'll keep in case I ever need to reuse them. And the last thing we need to do is remove this ring magnet from within this motor casing. Now that's quite a simple job. You'll see at the top here there is a gap just above the magnet. There's a gap in the between the top of the magnet and the top of the chassis. Just use that gap with a pair of pliers, just give it a pull, Some, again, a bit like the pinion gear, some will come out really easily like that one did. Others will need a bit more persuasion and a bit more of a wiggle and a tug to come out, but they won't be secured in by any other way than just being slid in. So they do just need to be wiggled and tugged and pulled on until they come out, and they should come out in one piece, which leaves you with your bare motor housing. Now I'm just going to bring my cloth in with my cleaning product of choice, bit of IPA or lighter fluid or something like that. Give it all a clean and a wipe, make sure there's no fluff, dust or grime or old oil that are going to impede the running of this model, and then we're ready to bring our new motor in and start to install it. So, as previously discussed, you have your motor. This one is the 6-volt slim variant because this is a Coco diesel model. Already housed in the 3D printed fitting adapter. And you have a paper sticker. Now the purpose of this sticker is to insulate the metal casing of this motor, because all of this of course is metal. It's to insulate that from the metal housing of the motor, because there is a risk that if you have the metal of the motor here touching the metal of the bearing or the metal of the chassis here, particularly if you're going to be wiring up for DCC use, you're likely to result in a short circuit. So by putting this paper sticker over, which you simply just peel off the sticker, you'll see there's a hole in the middle. That hole goes over the shaft on the motor with the sticky side of the sticker facing towards the motor. And just stick the paper sticker down. Now you may find that it won't actually stick to your motor. There's a probability that the motor will have a bit of oil residue on it from manufacture. That is not a problem in any way, shape or form, whether the paper sticker or the paper disc sticks to the motor or not, because of course when you put it in the motor housing, it is going to secure that paper disc in place. So if it sticks down, great. If it doesn't really matter. But put your paper insulating disc on your motor. And then we need to find that little stub axle that we took off, the one that was stuck to the magnet a bit earlier, that holds the center wheel of this side of the motor. We need to find that axle. And if you have a look at your 3D printed fitting adapter, you'll see that on the bottom flange just here there is a hole, and through that hole you slide this little axle, and you go from the shaft end through to the flat end, so that you will have that axle sticking out of the flat end of the assembly. So if I move that out of the way a second, so if I just offer the little stub axle up to the hole, just like that, and then push it through, and there's a tiny little gap in the bottom of the fitting adapter into which the flat head of that axle slots, which will stop it coming out or falling out. That is now secured in there. And once I've got that on, I can then offer the motor. So I've fitted my my paper insulating disc. I've fitted my stub axle, which is required for this type of Coco locomotive. And now I'm going to slide the motor in, wires pointing upwards, and I'm just going to offer it up so the axle, the output shaft goes through the center bearing, just there, and the two holes on the fitting adapter locate on the two locator pins on the chassis. And then what you need to do is give everything a squeeze, because what you will find is that the motor won't be completely seated in the plastic fitting adapter in the correct position. It's deliberately left so that you need to push the motor in a bit more to get it to seat properly. So give the motor a big push and squeeze, top, middle, bottom, all around the edge, and you should find that the output shaft sits nice and centrally in the bearing in the chassis. Now, one thing I will mention, if I just bring in a different type of chassis, this is a motor housing from a tender driven steam locomotive. If you've got anything like a Flying Scotsman or an A4, a Mallard, for instance, you'll find that your model has this sort of motor housing. Now, the actual assembly and fitting is exactly the same. However, if I grab myself another fitting adapter, what you will find is that the centre wheels, rather than being two separate loose wheels that slide over two sort of independent axles, one there and one there, you will find that you have a complete through axle with one wheel at each end, which just falls out of this slot here. So there's no need to worry about any sort of stub axle like that. It's surplus to requirements. And the 3D printed fitting adapter with the motor inside it, of course, will just slide in there, slot on there, and then all you need to do is obviously put your centre wheel back on when you've done. However, there are some occasions and some steam models with slightly smaller tenders. An example would be like a schools class, for instance, where the height of the tender is lower and the axles of the centre wheel actually won't go on once you've fitted this, because it gets in the way, because the axle is effectively needing to slide up to and beyond where my screwdriver is, and it's prevented from doing so by the bottom of this 3D printed fitting adapter. Now, unfortunately, I haven't got an example to show you, but if you come across this problem, it will be obvious what I'm talking about. If you don't know what I'm talking about, it means you haven't got that problem. But there will be some where you try and fit your centre wheels up and your centre axle up into your chassis, and the 3D printed adapter gets in the way and it won't allow it. The simple solution is just to take your wire cutters and cut away that bottom hole on the 3D printed adapter, making a nice little sort of triangle, if you like. Pull it away. So creating something that looks a bit like that, so that when you put it in your motor housing, there's nothing getting in the way of that centre axle sliding up into the motor housing. As I say, unfortunately I haven't got an example to make that illustration, but if you do come across that problem, then that is how you get around it. So we've got our motor in the motor housing. Now we need to secure it, and then we're going to reassemble the rest of the motor bogie. So to secure it, I'm going to use my two little E-clips. As I say, you will have some spares, and I'm actually going to tip the motor on its side, but I'm going to bring in, if I just bring in the magnet to rest the motor on, because if I rest the motor as it is on its side, you can see it's being lifted out there, because of course the output shaft is touching the desk and it's causing the motor to lift out. So what I'm going to do is just use the magnet and just rest the motor housing on the magnet so that it doesn't actually fully go down to my surface that I'm working on. So I'm just going to locate the two E-clips, one on each locating pin. I'm going to locate them by hand, and then I'm just going to use my fingernail of my index finger to hold that in place, and then I'm going to bring my pliers in and just squeeze it over that locator pin. There you go. And then once I've squeezed it over the pin, I'm just going to open my pliers over that pin and push down on the E-clip so that it's properly squeezing and holding the fitting adapter tight to and flush to the motor housing. And I'll do exactly the same on the other side. So I'll offer it up with my thumb and forefinger, use an index fingernail just to hold it in place, and then bring my pliers in and squeeze the clip on, and then push it down. So that is the motor secured. Now pushing against that motor shaft, that's not coming out, and I can put that magnet back away. So now I'm going to reassemble the gearing. So you remember we removed 4 pancake gears and a brass sprung clip that holds them all in place. Now the first thing we're going to do before refitting those gears is just apply a little bit, and I emphasize little, less is more, bit of oil on each of the gear shafts here. If you over oil it, your motor is just going to get really messy really quickly. You just need a tiny drop on each of those axles, and then you can bring your pancake gears back in with the brass retaining clip. Now, having given those gears a good clean, I'm just going to refit them. Now, with the single gears, you need to, so you've got two types of gear, a smaller single gear and a larger double gear. You need to refit the single gear first. Now, if you look at each side of the single gear, you'll find that one side has got some numbers embossed on it. Those numbers need to face inwards so that when the motor is assembled, you don't see them. So I'm just going to hold them with my tweezers and use my finger to locate them over the axle there. And the same again with this one. And then the double gear, I'll pick up this one first. So you've got a small gear moulded on one side and a big gear on the other. The small gear goes against the motor housing. So that one's going to go there. Oh, that one fell off. That one's going to go there. So they're installed, and then I just need to refit the retaining clip. Now this has got a slight curve to it, which you might be able to see in the video. The top here is curved that way. There's a curve that goes that way. So that curve effectively needs to go up and out. So when you're fitting it into here, the curve is going that way. So I'm going to just slide it in the top. And then locate it on one of the gear axles, just rocking it side to side to get it to move upwards. Locate it on, come on, that first one, and then up onto that second one. So those gears are now in place and secured. And the last thing we need to fit is the pinion gear. Now, the pinion gears come in fairly varied sort of widths. They're mass produced in China, and although the sort of diameter of the hole that the output shaft goes into is really reliable and constant and will fit snugly and tightly on your motor shaft, the actual width of the gear will vary by 1 millimeter or so. That might become relevant a bit later, and it might be that you need to just use a bit of sandpaper to make the gear a bit slimmer, and all you would need to do is get a bit of sandpaper and either use your fingers or a set of pliers and just rub it in a circular motion so it's even until you lose any excess width on the gear, and I'll explain why you might need to do that in a minute. So first thing I'm going to do is fit the gear, just push it onto this output shaft. Now it is a very tight fit. They're size for size, so you do need to give it a bit of a squeeze. And when you're squeezing or pushing the gear, you need to brace against the back of the motor itself. You can't rely on the 3D printed adapter or these E-clips to take that much pressure that is required for you to push this gear on. So make sure that you're bracing your thumb against the actual motor, not any of the sort of fitting accessories. And I'm just going to locate the gear over the output shaft, and then with my finger just push it on. And then once it's located and pushing on, just use 2 index fingernails and keep sliding it on until it's well engaged with those pancake gears there, which that is. So that is the motor installed, and now what we're going to do is just put everything back in the bodywork. So I'm going to put my wheels back on. So one wheel, I'll show you the difference between the two wheels. One has got a gear moulded on one side and one is all metal. So the one with the gear moulded on goes on the side with all the gears on, which is quite helpful and easy to remember, and the all metal one goes on the other side. And then making sure I've got these the right way round, because one of these tabs at this end is thinner than the one at that end, and you will find that on this housing, one of the gaps, one of the openings, is thicker than the one at the other end. So you need to make sure you get that the right way around, and you locate the thinner end first, and then the thicker end should just push into place with a bit of a spring action. Now, the width of the gear becomes relevant here, which hopefully I'll be able to show you. If I move my light over a little bit, you'll see that the gear is in quite close proximity to this little part of the housing. Now, this gear isn't rubbing and isn't catching. However, you could find, let me move my light a bit more, try and illustrate that a bit better. It is possible that you could find that having fitted this, that the gear actually catches on some of this bodywork here. Now, if you do find that that happens, you'll need to take this off again and just pop with it using a flat-headed screwdriver, ease that gear off, and just do what I demonstrated earlier with a bit of sandpaper to make the gear a bit thinner. Because if the gear is rubbing on that bit of the bodywork, it's going to put an awful lot of back pressure on your motor, and you're going to lose an awful lot of in performance. So you need to make sure that that is not happening. So that is the motor installed in the motor bogie, and the wheels reinstalled, and the bogie housing put back on. We're just going to refit that into the chassis. So the coupling end is this end. That obviously means that that goes that way round, because you need the coupling pointing out at the end of the locomotive. You'll see that there's two little tabs, one here and one here. This one has a chamfer, so it's sprung. This one is at a right angle, so it's not sprung. So you need to locate the one, so put your wires through the hole and locate the tab on the unsprung end first, and then push the sprung end through. And there you have your motor installed in your chassis. And the next thing we're going to do is wire it up. Now, in this video, I'm going to be wiring this up for analog use. If you're going to be wiring your model up for digital use, so installing a DCC decoder, then you can stop watching this video now and have a look in the video description, where you will find a link to part 2 in this series, which is wiring this up for DCC. So you can stop this video and you can pick up part 2, where we look at wiring for DCC. What we're going to carry on doing in this video is wiring this up for use on an analog or a DC layout. So having fitted that motor, we now need to think about how we wire this up for use on an analog layout. Now, obviously you've got two wires coming out of the motor, you've got black and red. It's really quite simple. The black wire goes to the dummy bogie at the other end. So effectively what we'll do is we'll cut this wire, twist these together and solder them. And the red wire goes to the motor bogie, the metal chassis of the motor bogie. And again, what we'll do is we'll cut this wire. We will also cut this one that we earlier took off of the motor bogie, strip them back, attach them and solder them together. And then your model will be running on on DC. So the last thing in the packet that we haven't used yet is the heat shrink tubing. This is where this comes into play. Now you get a length of heat shrink tubing. First thing you need to do is cut it in two, because you've got two solder joints to insulate. Depending on how long the length of tubing is, you might actually need to trim those down even further when you've actually got your solder joints together. So if I first do the black wire to the dummy bogie, clearly you can see with these two lengths of wire here, I don't need them to be that long. So I'm going to trim both of those down, strip them back, twist them together and solder them together. So trimmed the length down a little bit. I'll take my wire strippers. I'm going to strip back about 1 centimetre of bare wire on each of the bits of wire. And then I'm going to take one of my bits of heat shrink tube, and I'm actually going to cut it in half again. I don't need that much. And I'm going to slide that bit of heat shrink tube over the wire on this end, because this is the slightly thicker gauge wire. So you'll find it much easier in a minute if you slide your heat shrink over the thicker wire before you make your solder join. Now you must remember to slide your heat shrink over one of the bits of wire before you do your solder join, because once you've soldered the wires together, you then can't slide anything over that join to properly insulate it. And if you do find yourself doing that, you're either going to have to do a bodge with a bit of electrical tape, or you're going to have to disconnect the solder join and start again. And then all I'm going to do is take the two bits of wire, marry them up in one hand. So I'm marrying them up in my left hand because I'm right-handed. So you probably can just about see the two bits of bare wire coming out between my thumb and forefinger. And with my other hand, I'm just going to twist them together. And I'm going to twist and twist and twist so they're nice and tightly and securely twisted together. And then just take my soldering iron and some solder and just apply a small amount of solder there. It doesn't need to be much, just to secure those bits of wire together. Having done that, I'm going to bend the join towards the thinner wire, flatten it down, and I'm going to slide my heat shrink tubing over that join to properly insulate it. And then I'm going to apply a bit of heat, because heat shrink tubing is heat shrink by name, heat shrink by nature. When you apply heat to it, it shrinks over the join. So what I'm going to use is my soldering iron, but I'm not going to go anywhere near the end of the soldering iron with this heat shrink. I'm going to do it all up here. Don't touch the end of your soldering iron against that heat shrink tubing. Just lightly rub your soldering iron over that heat shrink tubing. Don't want to melt it, so just do it nice and lightly and quickly, and that has shrunk over that join. So that's that join done, and that can be tucked away. And then the last join we need to do is this piece of wire here to this red wire, and that will connect to the chassis. Now there's two spade connectors on the end of this wire. There's one with more of a triangular profile and one with more of a sort of rounder profile. The one with the rounder profile is like brass in colour, and the one with the triangular profile is more of a silvery colour. You want to keep this end, because this is the end that slides over a small little tab on the chassis, which might not be visible to the camera because it might be hidden by some of the other bodywork, but there's a little tab just there, and that is what this needs to slide over. So we need to keep this. So I'm going to snip this piece of wire by cutting it right at the end with the spade connector that we don't need, so that I've got as much bare wire as possible to strip back and join. I'm going to cut that. I'm going to strip back 1 centimetre or so, and again with my red wire I'm going to snip that down. I don't need it to be as long, and I'm going to strip back 1 centimetre or so. Take my other bit of heat shrink tubing, slide it over my red wire, and then take this bit of wire here, hold them together in one hand, twist them together with the other, and they should stay together like that. And again, bit of solder over that to secure them together. Bend the join so it's flush with red wire. Slide your heat shrink tube over that join and apply some heat. And then I can simply slide this spade connector onto that tab that we pointed out earlier, and there you have it. Just bend your wire down out the way. You just want to make sure that your wires aren't going to get caught up in any of your gears, so bend them onto the other side. Now there are a couple of different variants of Ringfield motor which have a couple of different ways of picking up power from the motor chassis. On a lot of the sort of BoBo motors, like your Intercities, etc., you'll find that the chassis doesn't actually have any of that metal sort of tab, and it doesn't actually have that wire at all. And what you will have found is when you took the keeper plate off, rather than being a keeper plate that looks like this, being the one that we just took off, it's slightly different, and it looks like this. And it doesn't have the two motor contact strips attached to it, but the contact strips are separate and they're held on by two screws. So you will have had to have removed those two screws to take the motor contact strips off, take the keeper plate off, and then you will find that there's a screw hole there. Now, with that screw that you removed from that screw hole, you're going to need to put that back in after you've fitted your motor. So you fit your motor, which I'm obviously not going to do the whole process of, and then you put that screw back into that hole. Why don't I use a screwdriver to do that, I hear you say? Well, let's give that a go. Now, the way these particular motors work is the power is picked up by the wheels in exactly the same way, transferred into the metal chassis, but then instead of transferring the motor from the chassis to the motor with a wire, it is just grounded into the chassis by this screw. So you need to refit that screw, and then your red wire here, you would literally strip back a couple of centimetres worth, wrap it round and round and round that screw, and then liberally apply some solder to attach that red wire to that screw, and that will connect your red wire to your chassis, which will pick up the power from one of the rails. Other variants of that motor don't even have that screw hole. They don't appear to have anything at all, and what they actually do is they have a keeper plate where you can't actually see this strip here because it is behind the keeper plate and pressed against the metal of the chassis. What you will find, however, is that you do have the little metal tabs on the chassis on which to slide a spade connector. So in that scenario, what I would do is take the bit of wire that we previously cut from the dummy bogie, which has a spade connector on the end. You'd have to open up the spade connector slightly with a screwdriver and then slide that onto that metal tab to make it work. Now, the other thing that's worth mentioning is some of these chassis have very, very short pins here and here. Now, they are the locator pins for the motor. And you'll remember that what we did is we put the motor in place and then we slid two little retaining clips over those pins. Now, some chassis, those pins are so short that you haven't actually got any bare pin to slide the retaining clip in place once you've fitted the 3D printed fitting adapter. The simplest way around that is to just use a bit of glue. So before you fit the motor, put a drop of glue over each of the pins, and I would suggest something strong like Gorilla Glue or epoxy resin, and then just slide your motor in and in place. But what you will obviously have to do is secure that and hold that in place until the glue goes off before completing the rest of your job, and make sure that when you're putting, particularly when you're putting the pinion gear back on, that you're not putting any pressure through this adapter and you're properly bracing against the back of the motor. So that is now fitted, that is ready to run. So what we'll do is we'll pop the body back on, which simply slides on and clips on all the way around, and then we'll go over to the test track, we'll put it on the track, put some coaches behind it and give it a run. So I hope the purists will forgive the rake that I've put behind this model. Just a few Pullman coaches that I was able to get to hand. One of the main benefits of upgrading your original Ringfield motor to these motors is you get much better slow speed running, much smoother acceleration and a much better crawl. So what I'll do is I'll just crawl backwards towards the centre of the shop just to show you what the slow speed crawl is like, and then we'll go for a proper lap around the test track. can see that it's just moving, just crawling. There you go. So that, performance-wise, would never be achievable with a Ringfield motor, that sort of crawl. They're just not capable of it, whereas these new CD drive motors are, which is one of the benefits to them. So let's reverse that and go for a lap around the track. So you can see the acceleration is also quite smooth. As is your deceleration. Bring it to a stop there. So there you go. I hope that's been a useful tutorial. I hope that will be of benefit to you when you fit your motors. And as I say, the performance benefits are significant. You'll have much smoother running than you would have done in your original Ringfield motor. I've obviously fitted the 6-volt slim motor to this model. The 12-volt motors have just the same, if not even better performance, because you still get the slow crawl, you still get the smooth acceleration, but you also get much more pulling power with those slightly beefier motors. So thank you very much for watching, and I hope it's been useful for you.